Okay. In this case, we want to find A intersection B minus C using the number line. Now, in this case, we're starting with the universal set as usual. Show the universal set. In this case, the universal set is from, of course, 10, negative 10, where negative 10 is part of the set, and positive 10. Now, here we have A intersection B. So we can show A on the number line. We have a negative 2 to 2, where both numbers, okay, this number is part of the set, and this one is not part of the set, according to the bracket that is used. This one is closed, this one is open, so this 2 is not part of the set. To show that this is set A. Set B, it is from negative 4. Negative 4 must be somewhere here. We have negative 4 to 8. 8 must be somewhere there. And in this case, both numbers are not part of the set, so you're going to open it, and on 8, you open, you connect the 2, and this is going to be set B. From there, we can also find set C. Set C in this case is from 0. 0 must be between negative 2 and 2, so 0 must be somewhere there. 0 to 5. 5 must be between 2 and 8, so 5 somewhere there. And in this case, 5 is part of the set, so I can show that this 5 is part of the set, but this 0 is not part of the set, so you open it. According to the bracket, this one is closed, this one is open, this is open, showing that this 0 is not part of the set. That's why you are opening it there. So this is going to be set C. We are looking for A intersection B minus C. A intersection B is this one. A intersection B is this part here, which is the same as A. This is A intersection B. B and A, the common part is here. B and A. So this is A intersection B. Now, since this one is A intersection B, this is A intersection B, we are subtracting C. By using set difference, you remove C from A intersection B, and we're saying that A intersection B is this one here. This is A intersection B. We're removing a C. So when you remove C from this part, which is A intersection B, you remove this C here. We're just going to remain with this part here. So we are remaining with this part from 0, from negative 2 to 0. From negative 2 to 0. The idea here is to identify the brackets. Remember that we're finding A intersection B, and A intersection B is this part, then minus this one here, which is C. So when you subtract C from this one, you just remain with this space here, and this space is from negative 2 to 0. Now from negative 2 to 0, I want to check. This one here is in the intersection. Remember that A intersection B, this negative 2 is in A, it is also in B, so it was in the intersection. That's why we're going to check this one here. It remained there since we only removed this side. This negative 2 remained. But when you look at 0, 0 is in the intersection, but it is not in C. So which means that it wasn't removed. 0 remained there, so 0 is part of the set. Since we are removing C from A intersection B, and A intersection B is this one here, which is the same as A. Now we remove C. So if I'm removing all the elements that are in C from A, and we have observed that this is open, which means that this 0 is not in C. If 0 is not in C, it was not removed from this A, so it remained. That's why we're showing the shading there. And this here is A intersection B minus C, the one that we have shown here. And this is equal to, since this one is closed and this one is closed, this is from negative 2 to 0, where both numbers are part of the set. That's the way you're supposed to do it.